warm welcome to our studio guests today and to fellow travelers out in cyberspace. Thanks to that non-stop stream of zeros and ones. My name is Peter Gobets, co-founder of the Zero Project and moderator of the International Conference/Workshop on Zero. The Zero Project is a three-stage affair. There's a book project, an associated online event, and then the in-depth research program to follow. But today, session number 10, and we welcome yet another contributor to the Monograph on Zero book project, Dr. Celestine Zhou, Chinese Academy of Sciences in Beijing, People's Republic of China, to enlighten us about the rod numeral system used in ancient China. The Zero Project provides equal opportunity to all scholars from civilizations to document the early emergence of zero as a numeral. And China is known to have performed advanced mathematics very early on in history. So we welcome back as panelists today, Dr. Robert Lawrence Kuhn, producer-host of the popular PBS TV series Closer to Truth, and Dr. Anders Erik Hoogkarspel, philosopher and author in the Netherlands. Celestine, we are very keen to hear the thrust of your paper after briefly introducing yourself. Please.
Okay, hello everyone. I'm Celestine Xiaohan Zhou. It's a great honor to be invited to into this workshop, and I'm working in the Institute for the History of Natural Sciences, Chinese Academy of Sciences, Beijing. 3 years ago, I got my PhD of History of Science at the University of Paris Diderot, French. My PhD thesis and my present work are about the history of mathematics in ancient China, especially from the 13th century to the 16th century. And I'm also interested in, and I'm working on the historiography of mathematics, which is about how modern or pre-modern scholars interpret the ancient documents and how they will write the history of mathematics. So today, my talk is about the placeholder in numeration and the numeral zero in ancient China. Yes. My presentation, so I began my presentation. It contains 5 parts. The first, there is an introduction in which I will make a very brief introduction of the writing of history of mathematics in ancient China in English language, because for the readers who do not read Chinese, these scholars' works are the sources they could refer to, and many English explanations of the so-called Chinese mathematics are fluenced by them, or just repeat what they said. So I summarized what they said about the zero in China, and meanwhile I clarify the issue which will be addressed in my paper. The second part is an introduction of a decimal system and the place value system of numeration in China, which pave the way for the third part, which is about the placeholder in numeration and the calculation with this placeholder. The fourth part is about the important rules of calculation in which numeral zero is involved in ancient China, so namely the procedure of the positive and the negative. So last is a summary. A lot of content, so I will be quick about my this presentation. And since the first half of the 19th century, European sinologists or historians of mathematics have interested in the numeration in China, and on the basis of the very limited mathematical works to which they have access. The scholars like Lippi or Buell, they introduced their findings on the European to the European readers. So at the beginning of the 20th century, a Japanese scholar, Mikami, first systematically wrote the development of mathematics in China and Japan in English. So it serves the main basis of contents concerning the mathematics in China. In Garrity's very famous book, A History of Mathematics, and David Smith's History of Mathematics, and they all based on this part of Mikami's work. So, and Mikami has included chapters on Indian and Arabic influence on mathematics in China, and he assumed the employment of the symbol circle in Chinese mathematics works is derived from the Indian source. During the 20th century, Western historians like Needham cooperated with Wang Ling and Maslov, a French scholar. They have made more detailed description on the numeration in ancient China, and further, they have compared them with those discovered from the other old civilizations. Some of this research have been absorbed in the popular history of numbers, like Xiaohan's work, and helped to form an impression of the Chinese numeration in the Western world. Because of the limited newly discovered historical records or objects excavated, the mutual influences between the Chinese numeration and those from other civilizations still mainly remains an assumption and an assertion of a clear route of the transmission of mathematical knowledge is still waiting for more proofs. However, some new discoveries concerning the use of zero in Chinese historical literature and more reasonable interpretations of the related texts need to be introduced, which constitutes the main aims of this paper. So at first, a clarification of the topic, the purpose and the scope of the paper should be made before any statement concerning zero in China. So first, this paper do not aim at discussing directly the history of the so-called Chinese zero or Chinese zero, or neither inclined to use similar expressions. So to some extent, this kind of expression is not precise enough to allow us to inquiry the question on the study and might lead to confusion about the dynamic concept and the diverse use of in different contexts. For example, if one use the expression the Chinese zero or Chinese zero, use this expression to refer to an Indo-Arabic number, an elliptic symbol used in a context which is similar to modern mathematics or scientific word written by a Chinese person, the history of the so-called Chinese zero is relatively short, and such historical narrative will be, and a lot of historical narrative will be excluded. Especially for those in the early period. So this symbol systematically appears in the works as late as the beginning of the 17th century, during which European missionaries cooperated with the Chinese scholar officials to translate Latin mathematical works into Chinese. But it was not until the late 19th century the 10 Indo-Arabic numerals, including numeral zero, were introduced into China and were adopted in some translation of European mathematical works. Thereafter, the 10 numerals, including the symbol zero, used in scientific world in China has less and less disparity from those used in any other places in the world. As for the transmission of numerals between India and China, and that between Islamic world and China happened before 17th century, several pieces of evidence are also found in ancient literature or antiquity excavated. At the beginning of the 8th century, the president of the astronomical board and the director of the Royal Observatory of the Tang Dynasty was Gudama Sihata, or in Chinese name is Qu Tanxida, who was an Indian dissident born in the capital city of Tang Dynasty. He translated some astronomical material based on the 9 planets system under the Chinese title 九直历, which was included as one volume of his large work. At the beginning of this volume, Kutama introduced the India numerals and the method of calculation, but unfortunately, the extended edition of the 9 planets calendar do not include any symbol of these Indian numerals. However, it also makes a short description of the use of a dot in the space between digits. So in India, a small circle has been used as a symbol for zero. Historians have also found that such zero represented by a dot had already appeared in the 7th century India's manuscript and in the Cambodia inscription on the Indian influence. However, most historians agree that Kutama's Siddhartha's introduction of Indian numerals does not influence the way of using numbers by Chinese practitioners of mathematical science. So the question to be addressed in my paper is that in ancient China, how elements of function of numeral zero as a placeholder of a numeration and as a numeral in calculation in mathematics, how these functions were achieved in mathematical works or practices without a clear external influence. And this paper explores the abundant historical literature related to mathematics. It explores the progress of gradual emergence of a placeholder in the numeration and its representation in the procedure of calculation and in the form written down. It also discussed that in a mathematical context where a numeral symbol of zero is not clearly given, how general rules of calculation in which zero are involved are expressed and understood and adopted by the ancient practitioners. An examination of the placeholder in numeral must begin with an introduction of the decimal place value system used in ancient China. An embryonic form of decimal numeration appears in the divinatory texts engraved on the surface of oracle bombs or tortoise shell during the 14th century BCE to the 11th century BCE. The numbers in the oracle bombs script mainly consist of 9 numerals from 1 to 9 and characters 10, 100, 1,000, myriad, 1, 10,000. Variations of these symbols are given in my paper and it's quoted from the course book. So perhaps I can show on the slide. Yes. And because of the limited time, I skipped the introduction of the analysis of the pictogram of these numbers and the way of combination. But they clearly show a decimal system for numeration in the oracle bomb script. From numeral 1, every time it's multiplied by 10, there's a special symbol created to represent the number. Only relying on the 9 numbers and the symbols of 10, 100, 1,000, and the myriad, most of the numbers carved on the bombs or carapace are expressed. During the period from the 10th century to the 3rd century BCE, text carved or casted on the inner surface of bronze vessels provide historians abundant characters, the numerals among which demonstrate a close link to the engraved on oracle bombs or tortoise shell. Apparently, the bronze inscription numeration combining the symbol and yu, symbols representing tens, hundreds, and thousands, etc., adopting the additive principle and multiplication. This seems implied a less possibility of generating a place value system in which the position of a digit in a number determine its value, namely the powers of 10 in the decimal numeration. However, in the numbers found on the coinage from the 8th century BCE to the 3rd century BCE, the place value system of numeration is relatively obvious. Comparing to the numbers on the oracle bones, a prominent figure of the numbers on the coinage is that nearly all the symbols of tens in the number of the 2 digits disappear. Furthermore, even the symbol of hundreds in the number of 3 digits disappear too. For example, in the example of next slide, yes. For example, in the example of number 154, in this picture, the 3 digits are arranged horizontally, and the digit 1 in the position of 100 is arranged on the left, and the digit 4 in the position of units is arranged on the right. The symbols of hundreds and tens are all omitted. Only the positions taken by the digit determines the power of 10, by which the digit in that position will be amplified. So this way of expression, the number is very close to numeration by a configuration of counting rows. But in these numerals on coins, there's no solid evidence discovered supporting a placeholder has been used. Then is the counting rows numeration. The use of counting rows as a calculation tool has been reflected by the text of the 9 chapters on mathematical procedures. 9章算术 is also translated as the 9 chapters on mathematical art. Thereafter, we call it the 9 chapters. This book dates back to the 1st century BCE to the 1st century CE, but a clear description of the way of using counting rows to represent a number is recorded in Mathematical Canon of Sun Zi, completed at the end of the 3rd century or the beginning of the 4th century. At the beginning of the discussion about the method multiplication and division, the text reads, for all the methods of mathematics, the practitioner must first know the position where a digit is put. The 1 units are expressed by a vertical model, and the tens are expressed by a horizontal model. The 9 digits are expressed by arrangement of counting rows in 2 ways. In way 1, vertical counting rows represent digit 1, 2 vertical counting rows represent digit 2. Digit bigger than 5 will use a combination of a horizontal counting row representing 5 with vertical rows below. The first line shows the numerals from 1 to 9 in one way. So this is the vertical mode, 纵式. And in 1, 2, and it's a horizontal row to present digit 1, 2 horizontal counting rows present digit 2. And the digit 6, 7, 8, and 9 will use the combination of horizontal counting rows and a vertical row above, representing 5. In a number, the digit represented by the 2 ways appear alternatively. According to the description in Mathematical Canon of Sun Zi, the digit in the position of units, hundreds, and 10,000s uses way 1, and the digits in their neighbor position will use way 2. However, the earliest counting rows numbers are recorded in a manuscript titled Mathematical Canon of Ready-Made Rules, 历程算经, around the 10th century, which was founded in Dunhuang. In this manuscript, the last 2 number of each piece of pinch formula. Pinch formula is a short sentence in concise Chinese which certain rhythm composing a set of instruction of calculation which could be recited or memorized easily. So in the last number of each pinch formula is the product of multiplication between two digits. And they were represented by configuration of counting rows as shown in the picture. The number of the summation of all the products one gets after each pinch formula are also calculated and represented by counting rows. Like this, so adding all the products previously gives 108, so 108. So in this manuscript, we can find these symbols, the configuration of the number presented by counting rows. The cursive handwriting in the manuscript does not strictly make use of space or any other marks to avoid the ambiguous representation of counting rows. Number 18 is distinguished from 108 in the counting rows in the counting rows numeration by means of the different model adopted for digit 1 of the tens and that for the digit 1 of hundreds. The digits of the tens are in horizontal mode, while the digits of hundreds are in the vertical mode. So considering the fact that the characters in a pitch formula are written in a vertical line, and on the contrary, the representation of digits are listed in a horizontal line, there is not much space left between digits of a number. Thus, the change of the mode of digits in turn plays an important role to avoid the ambiguity in certain cases. If there's no space or any mark between digits of a counting rows number, the change of mode of digits is not sufficient to avoid ambiguity in cases like representation of numbers 18 and 1008. So in fact, these representation of numbers without space between digits do not faithfully reflect the actual physical appearance of counting rows on a counting board. Space between digits must exist and be carefully treated on the counting board. This point of view could be testified by the procedure of the method of multiplication or division. But also because of time, I skip the example of division using the counting rows. In the procedure of division conducted, one could naturally perceive that a vacant position in certain positions is necessary, no matter the vacant position is located at the end of a number or between digits of a number. In a commentary made by the 7th century commentator Li Shunfeng, a word 空觉, absolute empty, was used to describe the case in which there is no digit in a position between two digits. Taking advantage of the decimal and place value system of numeration in China, it's clear that even though there is no particular object or mark which is used to represent the digit 0 in a number, the vacant position between digits sometimes plays the role of 0 in a mathematical calculation. In the 13th century, a symbol of 0 frequently appears in numbers in Qin Jiushao's writing on mathematics in 9 chapters, 数书9章, and Li Ye's C-mirror of the circle measurements. For example, in the latter work, the integral part of a number 3056 was written as like this. In a mathematical procedure of Zhou Shijie's, another very famous 13th century mathematician, in his work Jet Mirror of 4 Elements, if numbers corresponding to coefficients of an equation are 0, their position are also taken by a circle symbol, like this. An example is shown in the configuration, which is corresponding to an equation writing like this, in which the coefficient before all these terms are 0. In the extant 15th century printed edition of mathematical methods of Yang Hui 算法, one could find that 0 or character 空, literal meaning is empty, is used in the written procedure of multiplication or division by numbers presented by counting rows in this figure 8. The symbol circle was used in the books concerning pitch pipe or calendar calculation. In Shou calendar, used since the second half of the 13th century, symbol circle was used more frequently to record numbers. The fourth part, from the perspective of modern mathematics, 0 is not only a placeholder, it is also regarded as an individual number which could be dealt with in calculations like addition, subtraction, multiplication, and division, etc. And there are rules which declare the principles of a calculation in which 0 is involved, such as the rules that the result of multiplication between a 0 and any number is always 0. The result of 0 divided by any number is always 0, and the 0 should never be taken as a divisor, etc. Before the end of 16th century, in Chinese mathematical literature, which do not show a clear influence by Western mathematical works, their authors do not directly state that the vacant position of the counting board, there is an invisible number as a placeholder. They did not state either a mark like a circle in the written counting road number system is a numeral. Further, a clear declaration of a further declaration of the principle in which 0 individually involved in general calculation is not found in mathematical texts. For example, in different kinds of multiplication table found in bamboo strips dating back to the Warring States period, in the mathematical canon of Sun Zi of the end of the third century or the beginning of the fourth century, or even in the 10th century mathematical manuscript, the pitch formula do not contain the pitch formula of multiplication table do not contain the case in which 0 is involved into any multiplication with other number. In the 13th century, a series of pitch formula for division appears in Yang Hui's work, on the basis of which a division by any number could be calculated. However, the divisors of this pitch formula do not include a number 0 either. However, in a mathematical method titled far-flung, a practitioner must have dealt with the cases in which a 0 is involved from a perspective of modern mathematics, and the ancient practitioners have summarized the rules for these calculations. The function chapter of 9 chapters dealt with problems related to solving what they are known as simultaneous set of linear equations. A problem of chapter function of the 9 chapters says like this. Suppose that if one sells 2 ox and 5 sheep to buy 13 pigs, one remains 1,000 coins. That if one sells 3 ox and 3 pigs to buy 9 sheep, one just have enough coins. And that if one sells 6 sheep and 8 sheep to buy 5 ox, one lacks 300 coins. So one asks what's the price of ox, sheep, and pig are. To solve this problem, the practitioner needs to place the counting rows on the counting board in a configuration like this. A slash over the counting rows represents the number whose property is opposite to that of the row's number without a slash. So this is one possible way to show this two nature of number. The former number corresponds to a number one calls negative number, and the later one corresponds to present positive number. However, the subtle difference, there are subtle difference between the calculation between these numbers and those between today's positive and negative numbers. A procedure of the positive and negative is recorded in the 9 chapters, this book, to solve this kind of problem. In this procedure, 2 rules concerning the calculation of zero appears. Because the rules are very concisely expressed, the interpretation of these texts of rules vary from scholar to scholar. A major process of function procedure is to eliminate numbers in certain position of the configuration of numbers, like this figure. After a series of elimination, only numbers of one certain object and its corresponding price. In the context of finding the price of each object, only these 2 numbers are left on the counting board. So by division between the 2 numbers, one could find the price of the object, and then the other price are deduced. So how to eliminate the numbers on the counting board without changing the relationship between the numbers? The 2 ways are recorded in this ancient book. One of them is to multiply, for example, b in certain position by a number a in its corresponding position of the configuration, and then carry out b times of deduction in each of which a is deduced from the product ab after the position where b originally takes is empty. Besides, the number in the same column with a and b need to be multiplied and subtracted from each other. So according to the context of the question, then the nature of the number is opposite with each other. The number are marked as positive and negative. When this number with positive signs are to be dealt in function procedure, the procedure of the positive and negative are applied. A better interpretation was given by Garhin Chemela, a French scholar. She gives the interpretation of this procedure, which is different from the former interpretations. And yes, this is the 2 rules of the procedure of the positive and the negative. It says if the number in the position which is to be eliminated are the same mean, the same name, the numbers with the same mean are eliminated from each other. The numbers with different mean are added to each other. In these works, positive refers to numbers that are marked by a character written as Zhou, positive, or negative refers to numbers that are marked by a character written as Fu. It was the numbers without any marked sign, rather than a positive number or negative number, as treated in modern mathematics, that were operated and calculated. In the mathematical methods explaining in detail the 9 chapters, it's a 13th century mathematical book. A configuration of numbers could support this interpretation. In this figure, 2 numbers, 6 in the middle position, are marked as positive and negative respectively, since they have different names. Rules 2a and 2b are applied to each pair of numbers in corresponding position in the 2 columns. The 6 are positive and the 6 are negative are not added with each other as one thinks from the perspective of modern mathematics. On the contrary, the columns where the numbers belong to are called minus and subtrahend in terms of subtraction. The subtraction is precisely corresponding to the term elimination, 除, in Rule 2a of the 9 chapters. So, however, there are some cases which are not covered by sentence 1a and 1b and 2a, 2b. In these cases, there is not any number in a position of a configuration of function, this vacant position is corresponding to number 0 from the perspective of modern mathematics. However, for the ancient practitioners of function, this is not a number in this position. That's a character com, literal meaning is empty, is taken in that place. The sign positive and negative could never be marked on a place without any number. Therefore, sentence 1A, 1B, or 2A, 2B cannot deal with cases. So in these cases, sentence 1C or 2C are used, and I give a translation of them as follows. So if the positive has no number, yes, that's our interesting point. If the positive has no number to enter, one makes it to be negative. If the negative has no number to enter, one makes it to be a positive. In the right side of the figure 10, the 10,000 positive in the right column has no corresponding number in the middle column to enter. And since number 2 in the top position of the minute column has the same mean, which is positive, with the number 2 in the subtrahend column, the rules 1A and 1B are applied on numbers in the two columns. Simultaneously, sentence 1C should be applied to the cases in which 10,000 positive has no number to enter. That's one makes it to be negative. So the procedure of the positive and negative clearly demonstrate the case in which even though the numeral 0 is not introduced by Chinese practitioners of mathematics, but general rules in terms of certain mathematical methods, function, were still precisely expressed and applied to address the question, which must be solved by rules of addition and subtraction with numeral 0 from the perspective of modern mathematics. So this procedure has been recorded in the 9 chapters, which dates back to the 1st century BCE, and it was inherited by commentators and learners of this book in the subsequent hundreds of years. So that's then is the summary. This paper focuses on the question that in ancient China, how elements of functions of numeral 0 as a placeholder of numeration and as a numeral in calculation in modern mathematics are achieved in Chinese ancient mathematical works or practices. It introduced the decimal system reflected in the numbers of oracle Bohm's script and demonstrated the place value system used in the numbers on coinage. The decimal place value system was completely established in the counting road numeration. A description of the use of the counting rows to express numbers is found in Mathematical Canon of Sun Zi, and the earliest written counting rows numbers exist in a Dunhuang manuscript around the 10th century. Through conducting the procedure of multiplication, division, or extraction, even the extraction of root, according to the textual description of these mathematical methods, no one could deny that precise vacant position in the number are emphasized and strictly respected by the ancient practitioners, even though there is probably not a physical object or written symbol representing 0 as a placeholder. In the 13th century mathematical works, a written symbol circle is systematically used as a placeholder in number. In modern mathematics, 0 is not a placeholder, but also an individual number which could be calculated. Furthermore, a prominent demonstration of 0 is regarded as an individual number, is a clear declaration of the rules of calculation in which zero is involved. This paper interprets the procedure of positive and negative. This procedure is used in the context of mathematical method function, but general rules concerning the process of elimination numbers in an array in which from modern mathematics zero is involved are clearly expressed and adopted. So this case shows that in a mathematical context in which numeral zero has not been widely and clearly adopted, the elements of functions of zero could be achieved by its own means. So that's all. That's my presentation. Thanks.
Thank you, thank you very much. It's very interesting, but it'll take quite a lot of study to compare and contrast what you've said with what we have come to know. I think you've indicated that there may have been a misrepresentation by early Western scholars interpreting Chinese mathematics that have later been adjusted. So that'll take some study as well to make sure that we understand it correctly. We will definitely revert to that. I have one question before I ask Robert and Eric to introduce themselves and to ask any questions. Do you think that the use of zero, either as a placeholder or as a numeral, is it purely a product of mathematical practice, or do you see any connection to philosophical influences within which Chinese mathematics evolved? Do you have a view on that?
Yes, because at present I just focused on the mathematical documents, and in these documents I have to say that there's very little evidence showing that the use of zero or the placeholder or the numeral zero has some relations with the philosophical sense. But when they call the position, empty position, they used yes, just as I mentioned that they use a word. I think this word maybe have some philosophy sense. Is called absolute empty. So it's 空觉. It's a word used by the 7th century commentator. At that time, the Buddhist, the concept of Buddhist have entered China and have a great influence at that time. But so the empty, the concept of empty, has been formed a word, a vocabulary for the commentators of the mathematical works, and they use this word to describe the position, the empty position, absolute empty, to designate this position. So I think maybe there's some relationship, but in the mathematical documents, actually mathematical documents, the evidence is really rare.
But earlier than the 7th century, when you say numbers were manipulated properly according to particular algorithms that have been developed locally, you're implying that zero was already being used, at least the empty place in calculation was understood to have meant, say, the absence of the power of a particular base. That was purely one a result of practice, just simply by manipulating numbers and learning how, maybe, I don't know what kind of system that they used that may have facilitated this, some sort of device other than rod numerals. But as far as you can see, as far as you know from your reading, there was, at that point, there was no philosophical influence as such. There was no, for example, a revulsion against this idea of emptiness or nothingness. It didn't have a particular charge to it, to your knowledge.
As for the numeration in the ochre bones, the ochre bone scripts, you mean?
Well, yeah. Well, starting there, they were without having the 9 numbers and no symbol for 0. They were able to calculate, and it depends on how they did that, whether they evolved some sort of algorithmic system simply, through other means. There are other means to do this. You can physically do it. You can, take shells or pebbles or whatever you want to use and physically count them and see what the result is, and then build tables that you can just use these by rote without really, really understanding in the modern sense of what was happening. You could just practically get the correct results. And this is the issue that we run into in other civilizations as well. We don't know exactly how they calculated, and so we don't know exactly if they understood 0 to be a number, or whether it was just something that came out of the mix of practicing mathematics. Okay, but that may be too fine a point at this stage. Let's revert to that. We have your presentation, we have your paper, and we will put it in the larger context of all the other presentations and papers. And I'm sure we're going to revert to this and maybe even devote some special sessions to getting a couple of scholars together on this particular issue, which is really the key issue of the Zero project. We want to understand how it was that after tens of thousands of years of calculation and mathematics, without 0, that 0 evolved out of that. It's a question that has not been addressed directly head on, and certainly not in any interdisciplinary systematic approach. We'll revert to that. Excuse me for diverting momentarily. Robert, we've kept you waiting long enough. So thank you very much, Celestine, for this presentation. We're going to revert to that in a minute with some questions from Robert and Eric. Robert, thank you for taking the time from your busy agenda. We know how busy you are, but I say your reputation precedes you. So please, nevertheless, introduce yourself briefly and then pose any questions that may have arisen as a result of listening to Celestine.
Sure.
Robert.
Thank you, Peter. It's a pleasure to be here in the Zero Project. I'm the founder, writer, host of Closer to Truth on philosophy and science on YouTube and on our website, closertotruth.com. And it's a pleasure to be here. I thoroughly enjoyed the presentation. Fei Chang Yo Isa. I really enjoyed it very much. It was very interesting. A couple of kind of broad questions to see the context in which the mathematical developments of placeholder 0 developed. First of all, from your earliest presentations in terms of the early history, it seems like a base 10 was there from the beginning. Are there any indications of a mathematical system that has a non-base 10? I think the exploration of the nature of the base is an interesting one. Obviously, there are different ways of doing it. You can have a base 60 in the Babylonian system. Was there any earlier or any indications whatsoever of a different base system other than 10?
Yes. Yes, of course, we have other bases for numeration. For example, the when they calculate the year, when they calculate, the ancient practitioner calculate the time, they use the 60 ganzhi, how to say, it's a combination of the 12 symbols, and the how to say branch. It's and the 60, these 12 elements, and to multiply at 5 the 10 earth elements, and so the circle of this combination of these two elements is 60. So 60. So they count the numbers, count the years, the months on the basis of this 60. So this is another way of calculation.
And did that? Do you know when how that came from? Did that come from Babylonian, or how
yeah, we have no clear evidence to show that the influence from with the actual civilization. It's very evidence.
It's an interesting way of thinking, to compare whether some things develop naturally, like a base 10. We have 10 fingers, so maybe that's
Yes.
a natural base 10, and to see if things develop more naturally, or the same idea developed naturally in two separate places, or was there a transmission? So that's an interesting point. Second question I had was regarding some of the original systems that you had. It seemed to be reminiscent of matrix algebra, the way matrices and determinants are formed. Is there any association between how the ancient Chinese system was developed and what later became known as matrices and determinants?
You mean this kind of algebra I showed on the QC? Yes, this is the 13th century mathematical book, and they use configuration of numbers on the counting board. And this, in fact, this is written, it's printed in the book. And this configuration of numbers, if we rewrite this configuration in modern mathematical ways, so it's corresponding to the equations like this. So this is, and the circles in these configurations are the coefficient of the before this x, y, z is coefficients before these terms.
Yes.
So yes, and they use ways, and the ways to solve these algebra equations is called the four elements. The procedure of four elements, and in the 13th century, it has been advanced. Is a very developed. Is already has been a developed method to solve this kind of algebra equations. Yes.
Okay, and last question has to do a little bit off topic, but related, and that is the development of infinitesimals in China. I had seen some commentary on that in some work regarding the development of calculus, or something similar to calculus that developed with Leibniz and Newton in the West, the equivalent of when that developed in China, and how does infinitesimals relate to the concept of zero? Obviously, infinitesimals approach zero, but never are zero.
In ancient Chinese mathematical documents, I have not find as far as the methods concerning the procedure of positive and negative, and the procedure for the addition subtraction, we cannot find these things. No.
How about in more modern times? When do we first find the equivalent of calculus and infinitesimals in Chinese mathematics? Is it just coming from the West, or did it develop something similar indigenously?
No, I think it's just come from the West in the 19th century, as in the late 19th century.
Okay.
Yes.
Okay.
It's introduced from the West. Thanks.
So to respond to that from my side, again, zero evolved within the system of mathematics, leaving aside for a moment philosophy. But it was unrelated, as Robert was saying. When you start working with infinitesimals and you start realizing that, you know, the larger the denominator, and as compared to the numerator, you will be approaching zero. So the concept of zero in China did not emerge as a result of reflecting on infinitesimals. So we can maybe that's an interesting distinction, because in some other places that may have been the case. That leads people to think that if you divide, if the denominator gets large enough, you approach zero. The idea of zero could have emerged from that.
Right.
But that does not seem to have been the case. Eric, a few words about yourself, please, and then ask a question or two.
Well, I'm just a philosopher, and been practicing philosophy in the West, in Western philosophy, and also Asian philosophy. And from that comes my first question. Xiaohan, you said in your interesting paper that emptiness is called Kong, and it is indeed because I found it in translations already from the 4th century, from Buddhist texts by Kumarajiva, and still, of course, in today daily Chinese, still the word Kong is used in the sense of being free, or the sky being without clouds, and so on. But there's another word for emptiness, which is Wu, and it's already used in verse 11 of the Tao Te Ching, where it said that the use, the young of several things, comes from their emptiness. A jug is, you can put flowers or cereals in a jug because it is empty. And then the word Wu is used. So the word goes that Kong is just for Buddhist in the Buddhist environment, and Wu is for the Taoist environment. But I still have doubts. My question is there anything different? Is there any difference in meaning between both words?
Sorry, excuse me.
You have the word Kong for empty, and there is the word Wu. In the Tao Te Ching, verse 11, it said that a jug is useful because it is Wu. There's nothing in it.
In the mathematical documents, perhaps I have shown that on my slide. Could you see? Yes, on this slide we can find the Kong. This character Kong is used to as the character Kong is empty. It's a concept similar from the concept of Buddhist concept has been used in this configuration, and this is used as an alternative as the circle. In the same page, we can see that the circle and the character Kong empty used without difference, without any difference. These two symbols, but in these roots, of the positive and the negative in the 9 chapters, which is the 1st century BCE or to the 1st century. They have used the 无入. So the 无入, yes, 无入. The 无入, the literal meaning is the other operand is equal. No, the literal meaning is, or some philological proof shows that it's not 入 enter, it's 人 people. This character, because the 2 characters are very similar. The Chinese characters, the enter and the people, the 2 characters are very similar. So some people interpret that this should be the people. The people means the company. So 无入 no place to enter, or no, there's no company. I don't know whether these 2 words, the 无 used in these rules, have influenced by the Daoism. Sorry, I cannot give the philosophy interpretation of this sentence. I just focused on the mathematical use of these 2 rules, and I focused on the even though there's, you see in the 2 rules there's no numeral 0 is stated, and he just used the no place to enter, no company, but the rules are stated clearly, and the rules can be used, can be adopted to solve the very complicated simultaneous equations. So that's my point. Even though no numeral 0, but the rules are given and the rules are used very well.
Okay, thank you. My second question, yes?
Yeah, please.
My second question is there any sign of influence of the use of the Xuanpan, the Chinese abacus? You know, it's
Abacus. Yes,
this one. It's in use for centuries and very popular. Has been very popular along the Silk Road up to Afghanistan. But does it have any reflection on the developments of mathematics?
Yes. As far as I know, the Xuanpan has been used from the Song Dynasty, about the Song of Nansong Dynasty. Is about the earliest documents concerning abacuses appeared in the 13th or 12th century, and it was popular during the Mingqing Dynasty. It's about from the 14th century to, and after 14th century it became popular and popular. But as for the mathematical methods, the abacus is just used for the addition and subtraction, and even
commercial.
Yes, we do have the methods for multiplication and division and even extraction of roots, but the later 2 methods is used very rare, and in this device I can't say can reflect the concept of 0. I don't think so. It can be yes, related to the concept of 0.
That's clear. And also the date is rather late, from the 12th century on, so it's really without outside the range that we're looking, because historically it's clear that there was a time when there was no 0, and there was a time when there was 0, and there's a large window in between, but 12th century is already quite outside of that. Gentlemen, we're running a little late, not at all a problem, because it's very interesting, but we should now move on and wind up, if you don't mind. Celestine, we usually conclude all of these sessions with a very brief survey just to judge, to gauge general trends. So please just reply in one single sentence. There's no discussion, no elaboration. Was the numeral 0 discovered or invented?
Numeral 0 in ancient China mathematics, the numeral 0 is not invited, is not declared clearly, but I want to say that the rules are declared. The rules, which from the perspective of modern mathematics, there must be 0, the numeral 0 used in this question.
No,
but we can solve them.
No, that's clear. That's clear. You've explained all of that. The question is simply when it was used, and it was used in your view or in other views as a numeral, was that a discovery or was it an invention? You can also say I don't know, but discovered or invented, or neither.
Invented.
It's invented by somebody.
Invented.
Okay. Question 2: this transition between the placeholder and the numeral, whether symbolically represented or not, this transition between the placeholder, clearly use of a placeholder, and the use of 0 as a numeral, was it a gradual evolutionary process, or was it a sudden disruptive moment when this started?
It's a gradually evolution.
Gradual,
yes.
Evolutionary. Okay,
gradually.
Finally, now we'll harken back to the philosophical aspect of all of this, because it's part of our working hypothesis to explain, why the numeral 0 would come up where it hadn't been before. So, and that it may be related to this concept of nothingness or emptiness that also Eric was alluding to. But this concept of nothingness or emptiness in China, in ancient China, was it considered to be trivial or profound?
Considered as, sorry, what?
Was it considered to be trivial, say, very simple, no complication? It's just something that's there. Something is nothingness. That means there's the absence of something. Or was it profound in a sense that it had this philosophical depth to it, possibly?
I think perhaps the first one. I don't know, perhaps
I
need to.
It's not your specialty. You've indicated, you're not a philosopher. Eric is a philosopher, so hence the distinction. Eric, these 3 questions that we just posed, you've already had a shot at them earlier, so we just leave that for now. But we'd be very curious to hear from Robert what your take is on this key question about that you've heard discussed today, and whether it or not it brings us closer to truth.
Well, the journey closer to truth is very important for us, and we always leave out the, so it's not closer to the truth, which some people say, but closer to truth, a present progressive sense, as opposed to looking for some definitive answer. And I think that goes to to your first question about whether 0 was invented or discovered. I don't think that question. Well, I think that's a separate question from the whole concept of mathematics in general. And that's one of the themes of Closer to Truth, is to discuss mathematics. Is it discovered or invented? Discovered means that that mathematics exists in some Platonic heaven, as we like to say. Invented means that it's just part of the structure of human language. And so that's a profound discussion. Majority of mathematicians think that it is discovered and have a Platonic sense, but not all. And I think that's a legitimate question. And I think both sides have good points. Subset of that is whether, given that mathematics is either discovered or invented, what then is the subset of 0 within that? Is 0 just tied to mathematics in general? So if mathematics is discovered, i.e. meaning some kind of Platonic reality, then zero is part of that. That's not necessarily, that doesn't follow necessarily. You could have mathematics be discovered in that numbers are real in a Platonic sense, and yet zero be an invention. I mean, that's a logical possibility. That's probably not the case. It's probably the case that zero is part of the mathematical superstructure, whether of reality in a Platonic sense or whether a construct of the human mind. So I would tie zero to mathematics in general.
Right. Okay. Well, that sort of brings me back momentarily to the discussion we had with Celestine, whether it evolved purely within mathematics or there was some sort of philosophical grounding that is needed, that context, and conversely, that where this concept was not developed, that zero as a consequence was also not invented or discovered. But again, we're not going to settle that today, but these are exactly the key questions that we'll revert to after we've heard all of the speakers, which is a couple of months yet. But for now, let's wind it up. It's been over an hour. Thank you all for joining in the studio and also in cyberspace. Please tune in the week after next to explore further issues that may be related to pinpointing the epicenter of zero, if possible. And in doing so, you'll be helping us to draft a roadmap to do the research. Next week, we meet Professor Esti Eisenman in Israel on zero and the concept of nothingness in the medieval Hebrew tradition, and Professor Jamil Aysani on zero in the numeration system of the Maghreb. Thank you again. Until then.